Hello everyone, and welcome to another episode of AppSec 101. My name is Andrew Garrett, and I work in product marketing here at Fortify. And I am pleased to be joined today by my guest, Frans van Buul. And Frans is actually based out of the Netherlands, and he is a senior product manager for Fortify SAST. And before transitioning into product management in early 2021, Frans has worked as a Fortify pre-sales consultant since 2014 and has been leading the Fortify pre-sales practice in Europe since 2019. The pre-sales experience provided Frans with lots of practical knowledge of Fortify's strengths and challenges in everyday life, and now he uses this experience to steer Fortify SAST in the right direction. And before joining Fortify, Frans has worked as a security consultant and as a Java developer and architect, providing exactly the right background to go into SAST. So Frans, I am very honored to have you as my guest today as we discuss all things SAST. Is there anything you would like to add on to your background there?
No, this sounded great. Thanks for having me and a great introduction.
Absolutely. Well, with that, let's dive right into it. As I mentioned today, we're going to be answering the question, what is SAST? So to start things off, Frans, would you be able to give our viewers a basic introduction of SAST? What does it mean and why is it important?
Yeah, sure. So SAST is an acronym, stands for Static Application Security Testing. And it's a form of security testing that focuses on the source code of an application. So while doing SAST, you don't have to actually run the application. It's static, that's why it's called static analysis. It is very similar to what an expert auditor would do if they would be reviewing your code and looking for potential security problems there, except that it automates this process. To pull that off, a SAST tool needs multiple capabilities, needs to understand the programming languages that you want to analyze, it needs to understand the patterns that can occur there, the data flows that occur, the libraries that you're using, all that kind of stuff. Another important thing about a SAST tool is that, in its most narrow sense, what it does is look at source code and output results. In practice, that's not enough to run an enterprise security program. You need to have all kinds of integrations with IDEs that developers use, with build systems, but also you need to have some kind of system that can aggregate the results of many applications and many different scans, or some form of dashboarding, reporting. So when we talk about SaaS solutions in the broader sense of the word, that's also included with it.
Okay, so SAST is an important part of application security. And what are some of the strengths of SAST? And then also, what are some of the weaknesses?
So a strength of SAST is that it's scalable. So SAST primarily replaces the idea of an expert reviewer looking at your source code. But if you look at modern application portfolios, they may easily be 1,000 applications or more, and you might be releasing them every week. So if you want to review all of these applications before you put them in production, as you should from a security point of view, that gives you 50,000 reviews per year. There's no organization that can possibly pull that off with people. There aren't even enough experts in the world to do it. So a SaaS tool can actually do that. So that scalability, I would say, is its main strength. It's relatively fast. It's much faster than any of these security auditors could do it. So from that point of view, it's a strength. Some people also consider it a weakness because they want it to be even faster. So if you look at the speed of modern development processes, some organizations want to go into production many times per day. And if you do a SaaS scan of a big application that takes 2 hours, that may be a bottleneck. So in that sense, speed is a bit of a two-sided thing there. Another strength of SAST is that it can find many things also when they're not yet manifesting themselves as an actual vulnerability, just because it's a bad practice that could later on become a problem. SAST can already find it. That's a good thing. Can give very detailed feedback to developers, which is also a good thing because it allows them to fix the problem much quicker than if they would just get a vague description of the problem. Somewhat more negative side of SAST is that it tends to be a bit noisy. So not all the results that a SAST tool reports tend to be actually true. So those results are called false positives. And they are problematic because developers need to put in time to review them. They may lose faith in the tool if there are too many. So that's always something to manage if you're deploying a SaaS solution.
And I'm glad you touched on the importance of speed, because as we know, speed is so important to developers. So let's talk a little bit about the false positives for just a moment. You mentioned those as a potential weakness. So what are some things that can be done to diminish or reduce these false positives?
So there are many things. So first of all, any SaaS tool, including ours, can report their issues based on reliability levels. So in a very simple initial deployment, what you would do is just focus on critical and high issues, the ones that are very likely to be true, and just forget about the other ones. That's where the majority of the value would be. At a later stage, you might want to look at all the results, including the more noisy categories, because there is value in those as well. The key thing there to do is to not just make this a manual effort. If you have a big legacy project and you run it through a SaaS tool, you may easily have thousands of issues coming out of it. If someone needs to review each and all of them manually, well, they will take a long time, and they will also hate you for it, right? So that's a very bad influence into the overall success of your SaaS program. The better thing to do is to modify the settings of the tool. Think about settings that reflect the security posture of your organization, or any compensating measures you may have in place that make certain security things less relevant, or rules that model how you use particular libraries. All those kinds of things can be configured in SaaS tools to give the best possible results for your organization, which will reduce the noise without having to go through this effort of manually reviewing all issues. There's also a role there for artificial intelligence technologies that nowadays can review results coming from the regular SaaS tool and automatically recognizing the ones that are likely to be false positives.
Okay, so now that we have an understanding of SAST, let's talk a little bit about DAST and how SAST and DAST work together. DAST is, dynamic application security testing. So how does it differ from static testing? And is there any overlap between the two, or what's the relationship between those two types of testing?
Yeah, it's a good question. So DAST, that you said, is dynamic testing. The essence of it is that it runs the application, or that it uses a running application. And whereas SAST is like an expert code reviewer looking at your source code, DAST is more like a hacker trying to get into your application, and we're trying to automate that process. If you look at how they compare, they both have their strengths and weaknesses. DAST tends to be slower than SAST, just because it has to do with that network traffic. A big benefit of DAST is that it is less prone to false positives. That makes a lot of sense, because everything it reports is based on actual observed behavior of the application, so that is pretty reliable. It is also it is more than SAST prone to false negatives. If you misconfigure a DAST tool, it may fail to properly audit your application and you just miss results. So if you only use DAST, you have a higher risk of going into production with security vulnerabilities being undetected. There's some more differences. So DAST presumes that you have some kind of web interface on the application, right? That might be a traditional GUI, but it also might be a web service. That doesn't really matter that much, but it needs to have some form of network interface. SAST does not make that presumption. On the other side, SAST assumes that you have the source code, which may not be true if your application is being developed by a third party, for instance. And DAST does not make that assumption. So there are all kinds of scenarios where you may only be able to do one or the other. If you can do both, that gives the maximum reliability of results. There are some issues that can only be found using SAST, some issues that can only be found using DAST. DAST can help verify SAST issues. So if you're in a position to use them both, that's ideal from a security point of view.
Yeah, and I think that's a great point. You really need both SAST and DAST to get that holistic view of your application security posture. And that leads me into my next question, which you just alluded to a little bit. But why is it so important that security professionals and developers are using SAST tools? Could you elaborate a little more on what may they be missing out on if they're not implementing SAST into their CI/CD pipeline?
Right. And so if you look back at that argument about the scale of application security nowadays, it's pretty obvious that a manual approach just isn't going to cut it. Right? So if you're a security professional, you're responsible for the security of an application portfolio, you can only succeed by automating that. And SAST is definitely the most pragmatic, practical option to do that for your in-house developed applications. So you cannot do without that. A somewhat maybe less obvious question is, why would developers care as well, right? They could just develop and then try to fix things if the security professionals tell them to do so. The reason for them to care about SAST is inefficiency. If you, as a developer, run a SAST tool or have that run automatically in your CI/CD pipeline, you get immediate feedback. Then you can immediately act upon the issue and fix it. Right, so then the code is still fresh in your mind. You're still working on it. Nobody has to create tickets for that or explain certain problems. You can just do it. That's a very efficient process. If you don't do that, and it's just the security professionals doing the scanning, and they will detect things, something very different will happen, right? They will create reports, send that to you. They will start creating tickets in a ticket management system. You have to respond to them, look what that's all about, fix it, submit your application for rescanning. That's way more expensive and time consuming. So that's why developers should use these tools as well. And that's a phenomenon often referred to as the shift left of application security.
Yeah, and Franz, it sounds like you are advocating for DevSecOps, right? This is a term that we hear all the time where we're taking, DevOps and we are now integrating security in. We're building security into the process so that it becomes DevSecOps, which ultimately saves time for everyone involved, right? It saves time for developers, it saves time for the security testing team, because you're reducing the amount of rework, right? And so I think that is, critical. And let's, if we could, I'd like to maybe take a step back now and look ahead. Let's look at some of the trends that we're seeing right now in the industry and where SAST is headed. In your opinion, where do you see SAST going in the future?
Well, there are many things going on. It's a very active area. One trend that we're clearly seeing already happening right now is that customers are using SAST to scan everything that's code. And that may seem like a not so interesting fact, but the thing to keep in mind that there is a lot of code that's not really related to applications. We nowadays have lots of code that's related to infrastructure. Infrastructure as code, so Terraform, Azure Resource Manager templates, Ansible, things like that. So you might even wonder whether SAST is still the proper acronym 3 years from now, because much of the code that we're scanning nowadays is actually not related to an application. And there are many examples like that. So in addition to infrastructure as code, there are contracts as code, so smart contracts that run on the blockchain, written in Solidity mainly. We see scripts being used to configure infrastructure like Bash and PowerShell. Many statistical applications nowadays, often using the R programming language. We see CI/CD as code, so scripts in GitHub that can have their own security problems that people want to detect using static analysis technology. So that's a big trend, that proliferation of languages and technologies that people are applying SAST to. Another thing that plays a role is auto remediation. So right now, SAST tools suggest how you should fix an issue, but don't actually fix it. So that's still up to the developer, which takes some time. Now, in some cases, I don't think you will ever be able to do that in all cases, but in some cases, that fix could actually be implemented automatically by an algorithm. It would probably still be reviewed by humans, but they might just approve or not approve a particular fix. That might happen in the IDE. That might take the form of a pull request automatically launched against the source code repository. But something like that is definitely going to happen in the coming years. We already see this being experimented with in the related field of composition analysis. There, the fixes are usually to upgrade the version of a library, which is, in terms of the source code editing, you have to do relatively easy. But that type of technology is definitely also coming to the SAST field. Third one I want to mention is the non-traditional use cases. So traditionally, SAST is being done by scanning an application and then reviewing the results and doing something with them. That will still be important. But there are many other cases where you use SAST technology to power something else. So think about SAST, DAST synergy scenarios where a SAST tool does some initial analysis of an application. So a DAST tool can be more effective in the way it scans. Think about susceptibility analysis in combination with composition analysis. If we already know something about problematic libraries in an application, can we use SAST to detect if they can actually do harm? Also think about rules generation. Nowadays, most rules, so the security content of a static analysis tool, are written manually. And that places limits on how fast we can create it. And that's a problem because libraries and frameworks are continuously growing at exponential speeds. So what about it using the same type of analysis that we use to do static analysis of end applications, but now apply that with a slightly different goal to create rules that we would use when scanning other applications? I think that's also going to be big. There are many other things, but these would be the main ones on my mind.
Okay. Yeah, thanks for sharing your thoughts on that. I have to say I tend to agree with you a lot on where SAST is heading in terms of automation and machine learning. These automated algorithms that are just speeding up this process even further. And that leads me into my next point here, where I'd like to put in a quick plug for Fortify here with some of our SAST solutions with Static Code Analyzer, also with Audit Assistant. If you're able to take just a couple minutes and talk about what are some of the solutions that Fortify offers.
So Fortify is a broad application security portfolio that has SAST, DAST, composition analysis, all being delivered either on-premise or in a hosted version or as a service. That breadth of the offering is by itself a really valuable part of it. If you look at the individual components, so Fortify SCA is our solution that does the actual static analysis. It's characterized by supporting a broad number of programming languages, currently more than 30. And one of its key strengths is the large number of libraries it supports. So right now we, in our rule content, covers more than 1,000 vulnerability categories and 1 million different API calls. That is crucial to the effectiveness of a SaaS tool in reality. So that's why we strongly believe in that engine. Then if you look at what's around Fortify SCA in the portfolio, the Software Security Center can take in the results of Fortify SCA, but also other tools to provide this unified view and do the reporting. We have IDE plugins, and Audit Assistant, which you just mentioned, is our implementation of this idea of using machine learning and AI technology to identify and eliminate the false positives, so you get a more efficient process in the manual review.
Well, Frans, as we wrap up here, I want to say thank you for your time today. Thanks for explaining the basics of SAST and giving us a view into why it's important and what we should be doing. As we wrap up, do you have any final thoughts or any recommendations for our viewers as they look to improve SAST in their application security?
Well, a couple. So I would say, as a recommendation, if you embark on your SaaS journey, be very careful in selecting the right tool. Right? Of course, we prefer everybody to use ours, but regardless of that, with some important criteria. It's about library and framework coverage, which I already mentioned. It's also very important, and we see there are occasionally some misunderstandings there, to distinguish between static analysis tools that are mainly focusing on quality aspects versus static analysis tools like ours and some competitors' ones that really do security analysis. Both are forms of static analysis, but they're a different game. The quality analysis tends to be really fast, but quite superficial. Security analysis is the opposite. And that's fine, and both tools have their role to play, and most of our Fortify customers actually also use these quality tools. What's happening though is that some of these quality tools do a little bit of security, and that occasionally makes developers think that they actually are full-blown security tools, which is not the case. So when selecting a SAST tool, be very careful about this aspect. Final thing about those false positives. Be very careful to manage that appropriately. Like, the worst thing to do is to just use a SAST tool without any filters, let it run, and then send all thousands of issues on existing projects to developers. That will immediately blow up the support that you may have for your project. And that's not needed. You can be much smarter about it. We have consultants that can help with that. Many settings in Fortify allow you to tune it, but be wary of that aspect when doing your implementation.
Perfect. Well, thank you so much, Frans. Those are some great recommendations, great advice for us. And thanks again for joining me today, all the way from the Netherlands. Really appreciate it. And
Thank you.
And to our viewers that are watching this episode, thank you for taking some time to check out Fortify Unplugged. We hope you have subscribed to our channel. If not, please subscribe. We're always striving to bring you the best content around application security. And if you have any questions, please leave a comment down below. We'll make sure to answer that and respond back quickly. And so thanks so much for joining us today. We'll see you next time on another episode of AppSec 101. Thanks.
That's a wrap.
That's a wrap.